All right, this is a compound shape from workbook page 108, shape C. This is a page that you're going to have to solve. I want to show you how we can cut this shape in two different ways, and yet eventually we're going to have the same area for this compound shape. First of all, I cut it in this way: rectangle A, rectangle B, and rectangle C. As we agreed, I write the rule. Shape A is a rectangle, so I write area A is length times width. Okay, the length and width here are, the width is 9 inches, I guess you have it, 9 inches. What is the length? Can you see that this length is the same as all of these together? Because they are opposite each other. So this part is 6, this part is 8, and this part is 6. So this is 6 plus 8, 14, plus 6, 20. So area A is 20 times 9, which is 180 inches squared. Now let's go to area B. Area B again, the shape is a rectangle, so I write the rule, length times width. The length is 6 and the width, see, I only look at this part and I ignore everything else. This is the length and this is the width. The length is 6, the width is 5, right? 6 times 5 is 30 inches squared. Now, area C, length is 6, width is 5. So again, 6 times 5 is 30 inches squared. Now I covered the whole compound shape. I'm done with this, I'm done with this, and I'm done with this. 180 plus 30 is 210, plus 30 is 240 inches squared. Now let's try to cut it in another way. Again, 3 rectangles, A, B, and C. A is a rectangle, so area A is length times width. I only look at rectangle A. What is the length and what is the width? The width is 6. The length is 9 and 5 together. See? So it's 14. So 14 times 6 is 84 inches squared. Now let's go to area B. Again, it's a rectangle. The length and width are 8 and 9. 72 inches squared. Now let's go to area C. It's length times width, which is 14 times 6, which is 84 inches squared. Now, let's add them together. 84 plus 84 plus 72. 84 plus 84 is 168 plus 2, 170, plus 70 is 240. 240 inches squared. See, I got the same area, 240 inches squared. Although I divided it in a different way, the measurements are different. However, when I added them together, I got the same area. All right. There's one more thing that I want to tell you about finding the area of compound shapes. And it's a concept called shaded area. Why is it a shaded area? Check this out. This is a rectangle, and this is a triangle inside the rectangle. I want you to find the area, the shaded area, the one in the red. Can you imagine that this shape is a rectangle and I cut a triangle from it? So technically, can I find the area of the full rectangle and take from it, subtract from it, the area of this triangle? What would be left? Imagine that this is a piece of paper and you cut this triangle from it. This is what would be left, right? So what I have to do, let's write the measurements first. This is 10 centimeters and this is 6 centimeters. Okay, so if I want to find the shaded area, first of all, I need to find the area of the big shape. But let's say area big. What is the shape? It's a rectangle. So length times width, which is 10 times 6, which is 60 centimeters squared. Now this is the area of the small, which is the triangle. What is the rule? Base times height divided by 2. Please don't forget to divide by 2. It's a very common mistake. What is the base of the triangle? Any shape could be any side could be the base. However, from the measurements that I have this base. Let's label it in blue. This is the base of the triangle. This is the opposite vertex. I draw a perpendicular line. Can't you see this? This height is equal to the 6. So this is the height of the triangle. So it's 10 times 6 divided by 2, which is 30 centimeters squared. Shaded area is the area of the rectangle taken from it or cut from it the area of the triangle, which is 30 centimeters squared. So there's one tip that I want to tell you, which is if the shaded area was something that you can find the area for directly. For example, one of you might tell me, I can find the shaded area by finding the area of this triangle and finding the area of this triangle. It's true that the shaded area is technically 2 triangles, but do you have this? From the drawing, it shows that this is equal to this. But did I tell you that this is equal to this? I did not. So you cannot assume that this part is equal to this part and consider it the base or the height of the triangle. But don't do that. Unless I tell you that this is equal to this, very simple. no need to subtract and do all of this. You come and tell me, this is a triangle, this is its base, and this is its height. This is another triangle, this is its base, and this is its height. This is 5, and this is 5. Because I told you that this is equal to this, so the 10 is divided equally among these two. But because I did not tell you that these two are equal, please do not assume so and try to figure out another way. And this is one of the ways, finding the area of the big shape and cut from it the area of the smaller shape. And this will be left.